All right, one more gas law. This one is Gay-Lussac's gas law, and that involves the relationship between pressure and temperature. You'll know that you've got this down when you can do a Gay-Lussac's law calculation and just describe in general what happens with temperature and pressure as you change those with a gas. So here is Gay-Lussac's law. So pressure and temperature are directly related. All right. You are going to be keeping volume constant. Here's your equation. You also may see this version of it in your course. But it just means that your pressure divided by temperature is always equal to a constant value. So if you have initial pressure and initial temperature, and then you change one of those, the ratio of the pressure, the new pressure, and the new temperature is going to be equal to the beginning ratio. And again, just like with Charles' law, those temperatures need to be in kelvins. All right? So kelvins we're going to get into the details of exactly why with that next lesson. But just remember, make sure you're plugging kelvins into those equations. Celsius does not work. So we got another direct relationship. So if you guys remember your assignment from the Unit 1 test Part 2, you actually already graphed this relationship. But, as temperature goes up, pressure goes up. Or as temperature goes down, pressure goes down. So let's try this one. When you heat an air-filled sealed can, what happens inside? Just so you know, if you ever see something like this where it says like sealed can or rigid can, that means constant volume. All right, because, unlike a balloon, which can change shape, a can isn't going to be able to. So you're heating or increasing the temperature of a sealed can. So which of these is going to make the most sense? The collisions of the air molecules against the wall of the can are weaker and less frequent. The collisions of the air molecules against the wall of the can are stronger and more frequent. I spelled stronger wrong. And the collisions of the air molecules against the wall of the can do not change. So, what do you think? If you remember, pressure is defined as the collisions per surface area. So, if your temperature is going up, then according to Gay-Lussac's law, so should your pressure. All right? So, you're going to get more frequent and stronger collisions. So Gay-Lussac's law in math, just like all of the other ones, start by labeling what you've got in your problem. So the pressure of a gas is 0.5 atmospheres, so there's our initial pressure, at 120 Kelvin. There's our initial temperature. At what temperature, so T2 is our question, because it's asking us what temperature, will the gas have a pressure of 1.2 atmospheres? So there's our P2. Assume volume is constant. All right, so our equation is P1 over T1 equals P2 over T2. All right, so I'm going to do 0.5 over 120, and that is going to equal 1.2 over our unknown temperature. All right, and this is where your cross multiplication is going to come in handy, because sometimes it gets tricky when you got to solve for something on the denominator. So that's going to become 120 times 1.2. That's equal to 0.5 times t. So 120 times 1.2 divided by 0.5. So your temperature is going to be 288 Kelvin. All right. Confirm that that makes sense by looking at your pressure. All right, that increases, which means so should your temperature. And that went from 120 to 288, temperature increased too. So here's one you can try. Read this one carefully. So you have 0.5 liters of air in a rigid sealed container. All right, that means AKA your volume's constant. Rigid sealed container. At a pressure of 203 kPa and a temperature of 108 Kelvin, you heat the container to 273 Kelvin. What is the final pressure of the air? Pause the video, see if you can answer this one on your own. So we've got a volume, which is staying constant, so I don't need to worry about that. That's not going to be used in my equation, so I can actually just ignore that. I've got my P1 and my T1 and my T2. My question mark is P2. So I've got P1 over T1 equals P2 over T2. So let's plug in. P1 is 203 divided by 180, which equals P2 over 273. Cross multiply. So I've got 203 times P2 is equal to 180 times 273. 180 times 273 is equal to 49,140, which is 203 times P. Divide both sides by 203. Sorry for skipping that step last time. Divide that by 203, and I get a pressure of 242 point something something. So there's our pressure. You can also double check your thought. Your temperature increased, so your pressure should increase too.